Hello, chemistry students. Okay, we are going to start working in section 3. This section is about limiting reactants. So in section 2, when we were working a standard stoichiometry problem, we started those, and you will notice in your textbook that we were only given one piece of information. So we knew which piece of information started our math path. There was no question. One piece of data, that data has to determine our outcome. In this section, we're going to be given 2 pieces of information, and we have to determine which of those 2 pieces of information we can use. This is called determining the limiting reactant. So one reactant will be our limiting reactant, and one reactant will be in excess. All right, so let's get started. All right, so you're going to need your handy dandy math path here. So what we're talking about is having 2 pieces of information here. So we have to decide which one will determine what we can do. All right, so read this section. Look at the definitions. I'm not asking you questions from it right now. I'm going to depend on you to do that work for me. So these are limiting reactants. The limiting reactant will be the one that runs out first, okay? The one that will determine, how much product we can produce. So this is always about reactants, all right? So again, we've been working with 1 piece of data. Now we're going to work with 2 pieces of data. But guys, realistically, we do this kind of thing all the time. Working with leftovers and excess. So let's look at a real life example, okay? So let's say that you want, it's a beautiful day today. I hope you're watching this when the sun is shining. That's when I'm making it. So you want to go on a drive, okay? So you want to get out and go on a drive. So here are the constraints. You have 1 hour available to you, and you have a full tank of gas in your vehicle. So which one of those limits how far you can drive? Well, that's a no-brainer, right? 1 hour. 1 hour limits how far you can drive, because at the end of the hour, at the end of 1 hour, gas is still in your tank, right? So the full tank of gas is the excess reactant here. The 1 hour is the limiting reactant for how far you can drive. So let's flip this again. You want to go on a drive, and you have all day. You've done all your chemistry, you've done all your history, all your English. You don't have anything else to do. You have all day to drive, and you have a 1/4 tank of gas. In this scenario, which is the limiting reactant? The 1/4 tank of gas. Right? So time is in excess. The gas is the reactant that limits how far this drive can go. That is really all we are doing here, guys. So let's look at one more real life example. Okay, so I have a little bowl of candy here, and I want to make some little goodie bags, okay? And I want each goodie bag to have the same number of pieces in it. So I'm going to divide this up. All right, so let me give myself a blank. So I have 3 Starburst, and 1, 2, 3, 4, 5, 6, 7 Dum-Dums, 1, 2, 3, 4, 5 chocolates. They're not all the same, but that's fine. And then I have 1, 2, 3, 4 peppermints. Okay, so this is a no-brainer, right? We could do this kind of thing all the time. So I'm going to be able to make a goodie bag. Every goodie bag has to have the same amount of things. So I'm going to start with my limiting reactant. I can only make 3 goodie bags. So so each goodie bag can have 1 piece of chocolate. So I've got some chocolate left over. And each goodie bag can have 1 peppermint. I'll have some peppermint left over. And then each goodie bag can have a Dum-Dum. Oh, but wait. Each goodie bag can actually have 2 Dum-Dums. Right? 2 Dum-Dums. And then I have 1 Dum-Dum left over. So the Starburst was my limiting reactant. And then in excess, I had 2 chocolates, 1 Dum-Dum, and 1 peppermint. So these are my leftovers. I can't make, you might say, well, you can make a goodie bag out of that. Yeah, but all my goodie bags have to match. Remember, you can't have a molecule that doesn't have exactly the same amount of things if I'm trying to make a molecule. So that's where this really applies to chemistry. We're at a party. We could have a goodie bag where we short somebody a starburst, but we certainly can't short a molecule of an atom, right? Because then we have a completely different thing. So that's how that can help us understand that. So let's look at a couple of sample problems, or a sample problem here. How much magnesium oxide is produced when 48.6 grams of magnesium reacts with 64 grams of oxygen? And then we have a balanced equation. All right, so we'll see here. The problem that we notice is, well, I have 2 masses, 48.6 grams and 64.0 grams. So I can't, if I started with both of these, I'm not going to get the same answer. So I have to determine which of these will start my math path. And the way that we do that is by comparing what our balanced equation requires. All right, so let's look at this. The balanced equation shows that ideally, in a perfect situation, 2 moles of magnesium reacts with 1 mole of oxygen, 2 to 1. Do I have that ratio? That's what we're going to determine. Which reactant will run out first and which will be in excess. And you might see me write that excess, an X and an S, not extra small, but excess. So this is what we have to determine. So let's do that. Let's convert. So we cannot compare grams. Remember, we cannot compare grams. We can only compare moles, right? That's this. We can only compare moles. We can't compare grams of 2 things. We can only compare moles. So let's do that work right here. Convert each sample to moles. So 48.6 grams of magnesium using the molar mass is 2 moles of magnesium. 64 grams of oxygen using the molar mass of oxygen is 2 moles of oxygen. Well, I have equal amounts of moles. So what does that mean? Well, remember, the balanced equation says that we need a 2 to 1 ratio. 2 moles of magnesium react with 1 mole of oxygen. Okay, so that means if I use all 2 moles of this, then I will only need 1 mole of this. However, let's look at the flip. If I try to use all 2 moles of this, since the ratio is 2 to 1, I would need 4 moles of magnesium. Do I have 4 moles of magnesium? No, I only have 2 moles of magnesium. So the magnesium is my limiting reactant here because I compared. So which reactant will be used up first? Magnesium. Which one will have leftovers? O2. So the reactant that runs out first is the limiting reactant. Magnesium is the limiting reactant. So now let's solve the problem. 2 moles of magnesium. And now we're on our math path. Here we're just doing this. We're going from moles, since we already converted our 48.6 grams to moles. I'm just starting right here. Because my question is, how many grams of MgO? If we go back and look at the original problem, right? So we're going to convert moles using the balanced equation ratio. 2 moles of magnesium, 2 moles of MgO. Moles of MgO cancels. This is the molar mass, 40.305 of MgO. That's magnesium plus oxygen. And that, when we do, so 2 times 2 divided by 2 times 40.305 gives me an answer of 80.6 grams of magnesium. I can have 3 sig figs because of 3 sig figs in my original data. So now that's the answer to the first question. Now we were also asked how much oxygen will be left over. So let's look at this. Since we only use 1 mole of oxygen, that means 1 mole is left over. And if we look at the molar mass of oxygen here, 1 mole, that gets us 32 grams used. And then we subtract 32 from 64. So that means that 32 grams of oxygen is left over. All right, so pause, look at those, And now, here is your assignment. You have 3 questions to answer. A 54-gram sample of aluminum reacts with 508 grams of iodine. The balanced equation is given for you here. Please put the balanced equation in your work. You will lose points if you do not write that down. Now, you are going to determine the moles of each reactant, determine the limiting reactant, and then tell me how many moles of aluminum iodide are formed in this reaction. That's your first assignment. So 1 photo of this work. Upload 1 photo of this work. The second assignment is this. When silver reacts with sulfur, the compound silver sulfide is formed. And here is your balanced equation. Again, your balanced equation must be in your work. So here are the 2 things for you to do. When 4 grams of silver reacts with 4 grams of sulfur, what mass is produced? Now, this means you have to find the limiting reactant. That's a hint. Find the limiting reactant, then use the limiting reactant. Why am I whispering? Find the limiting reactant and use the limiting reactant to do your math. Okay? So it didn't specifically ask you that, but I'm reminding you. Now, how much of the excess reactant remains when the reaction stops? All right? So you've got a couple things to do there. Upload 1 photo of this work. And then your last question for this set. Go to page 383 in your textbook. Number 23. There are 4 parts. Show all of your work. Include the balanced equation and upload 1 photo of this work. So this should have 3 photos uploaded to this assignment. Just attach them one after the other. I'm looking forward to seeing your work. This is Limiting Reactants.